A little bit, so I don't talk quite as loud. We do to get the PA, but we'll go ahead and get started. My name is Brodbeck. I work with Auburn. I'm a research engineer. We're going to talk a little bit about gasification, some of the work we've done, in particular tied to the IBIS project. I know a lot of you guys are familiar with gasification, so I won't go too much into it, but I'm just going to talk a little bit initially. I have a video on the screen here that just gives you sort of a quick overview. And this is one we put together. We talk a lot with a lot of younger generations. That's why it's sort of cartoon-like. But gasification pretty much will take the material out of the wood, the biomass. We got to do some pre-processing, whether it's just chipping or if you want to take it further to pelletizing. And we'll take that biomass, we drop it into the gasifier. And what gasification is a thermochemical conversion of biomass using high heat. You guys hear me better?
Yes.
So with gasification we use high heat and an oxygen reduced environment. So we're trying to convert the biomass to carbon monoxide and hydrogen, but we don't want to provide a lot of oxygen, so we go all the way to carbon dioxide to get full combustion. So one of the nice things about gasification is that there's a lot of uses for the gas that comes off the gasifier. We call that gas syngas for short, synthesis gas, producer gas, wood gas. There's a lot of different terms for it. Today I'll just be calling it syngas. So coming off the bottom of the gasifier, we have the syngas, and our picture here comes off the side. There's different style gasifiers. The first thing you're going to do with that gas is you're going to do a quick cooling on it, get it down to a temperature you can work with, and then we're going to clean it up. And at that point, you have some options of what you want to do with your syngas. In the diagram here, we are processing that gas to continue cleaning it, running it through an additional reactor called a Fischer-Tropsch reactor, which then allows you to distill that gas and turn it into a transportation-grade fuel. That's sort of, in our opinion, about the ultimate product you can get out of gasification, because that transportation-grade fuel, the nice thing about it is that, apart not like biodiesel or some of the other fuels, it is a true drop-in fuel, meaning you can take that fuel, put it straight into a vehicle. It won't know the difference. The chemical composition of that fuel is identical to diesel or gasoline or jet fuel, whatever you're making. On this system here, we don't have the capability to go all the way to transportation grade fuel. We actually stop right after the heat exchanger right here. We do some initial cleanup to the gas, which is really just particulate removal. We remove ash and char, and then we take that gas and put it into a internal combustion engine to turn a generator. It gives us our final product on this system, which is electricity. So we're just turning a generator using our syngas. Like I said, the nice thing about syngas is it's quite versatile to use. You can use it like you would natural gas in a gas turbine, or you can make it transportation grade fuel. This is a quick overview of our system here. I know some of you have seen these. I know some of the Mississippi State guys have a system real similar to this. This is a Community Power Corporation. They built this system, and we've used it quite extensively for our research. But we have two bins in the front up at the top there where you can put in your biomass. Right now we're just running clean pine chips. Right now we're running clean pine chips. We drop them into the top of the gasifier. You can see them going in right now. And then we're using high heat. We convert that material to a gas. Temperatures in there are around 900 degrees Celsius, so 1500 degrees Fahrenheit or so. We come off the bottom of the gasifier, and we run our material or gas through a heat exchanger to cool it, our filter box to clean up, remove that particulate matter, and then into our engine compartment. With this system, we do have the capability to pull the hot air off of it and use it to help dry down our biomass. We like our biomass to be about 10 to 15% moisture content. We found if we get too much moisture than that we have a hard time maintaining the temperatures inside the gasifier. And if we get too dry, we have flames coming out the top of the gasifier, and we don't want anything coming out the top of the gasifier. Everything is going in and being pulled down. This is a downdraft gasifier. So, and then our final product on here, as I said, is electricity. This has a 25 kW generator on it. We use about 1 to 1.5 kW just to keep the system operating. So we do have a fair amount of electricity available for whatever our need may be. I know they said there would be no PowerPoint, but I decided to sneak one in. I just want to talk just a little bit. This is a study we just finished, looking at some of the different types of biomass of interest in some of the IBIS work we've done. We're not working here with any of the hybrid poplar or eucalypts, but we're working a lot with the switchgrass. And what we wanted to do on this study was compare the gas composition from hardwood, loblolly, and switchgrass. All those were pelletized. Look at what does the syngas composition look like, tar concentration, hydrogen sulfide. In particular, the hydrogen sulfide we're interested in because if we were to use the fuel for the Fischer tropes to make a drop-in fuel, it's a contaminant that we would have to remove. And the final thing we're looking at is just, does the material gasify well? And it's sort of hard to put numbers on that, but what I'm sort of talking about there is after you run the gasifier for a while, are you getting agglomeration in the bed that's going to cause clogging? Or you can be able to run that material for a long term. I put up some biomass characterization, and when I look at any sort of characterization, there's two things I look at right away. One is ash content, and the other is moisture. Moisture is easy enough to work with. We can dry material down fairly easy. Ash is a little more of a challenge. So the one thing I just want to point out here is the ash content of switchgrass, about 4.5%. That is at the threshold where we're going to probably have some issues with it. So that was one thing we were really wanted to look at closely during this study. If you look at our gas composition, what we've seen over the years of running this system, and this is comparing all sorts of types of biomass, is we don't usually get that much fluctuation in our gas composition. You can see the hydrogen, it's fairly stable. It's all right around 15%, give or take 1%. On this study, we did get a little variation in our carbon monoxide, which surprised us a little bit. In particular, you can see the yellow pine was a good bit higher than particularly the switchgrass, and that surprised us a little bit. And CO2 and methane are pretty stable. We don't really concern ourselves too much with those two gases, though. Across the board, the heating values are pretty stable because of the higher CO and the yellow pine. We did get a bit higher heating value for yellow pine. Switchgrass was still a little bit lower, but still fairly stable. The tar was an interesting one for us. We've run a lot of just regular pine chips through there, and we never see any issues with tar. But the second we throw the same pine chips and pelletize them and then gasify them, we get tar issues. So you can see the chart on the very left of the yellow bar. That's the yellow pine, which is the same material as pine chips. And the pine chips has the lowest and the yellow pine has the highest. And we think that's just a density issue, that it takes so much longer for the pellets to break down in the gasifier that we don't have much opportunity for the tars to get broken down as well. But one thing to point out here is that the switchgrass was fairly low in tar, which we were really happy about. Hydrogen sulfide, all values of hydrogen sulfide were pretty stable, and they're all above the threshold where we would have to do some cleanup, so not much to really be said there. As far as our fourth objective was how well does the material work? We found that because of the 4.5% ash in the switchgrass, that we did get enough agglomeration that long-term runs would not be sustainable in this type of system. So our second objective in the study was, well, if we can't run switchgrass continually, can we blend it with pine and make that work continuously? Once again, biomass characterization, we did a 50-50 blend, a 75-25 blend. And the big thing to look at here is the ash content, 2.5% for pine blended with switchgrass, and that shows us that, well, one, we can blend down the ash content, which is great, but then the next question is, well, how's that going to affect everything else? gas composition didn't affect much. The blend, once again, the CO jumped around a little bit on us, but we did see a little bit higher CO with the 50-50 blend. That's the green bar. Heating values are pretty stable. Tar concentration, we were able to get some of the tar down from the initial just yellow pine there in the green bar. We were able to reduce it because of the blend, which we expected. You know, such a low tar in the switchgrass, we expected lower tars once we blended it. Hydrogen sulfide didn't really change much either. But I guess the big takeaway from us on this study was that we can successfully blend biomass and we can successfully run it, which I think is really pretty important if you think about just the way crops are harvested and the seasons and all that. If we can start blending switchgrass with pine and materials like that, that's going to give us more year-round use of biomass, but also at least it's going to make, in our opinion, switchgrass usable in gasification, because up till now we have not been able to successfully run switchgrass for long terms. We can run it for short terms, but over long terms we keep seeing, and when I mean long term, I mean over 12 hours, so I'm not talking about months here, I'm talking about days. So, but now we're at the point where we could run switchgrass blended with pine for quite a while and end up with a good quality gas. That cars aren't going to be too bad, the heating value is still going to be good, and the gas composition is going to be favorable as well. So that was, for us, that was a big takeaway from this study, is the success in blending. That's all I have for right now. You guys have any questions?
When you said it wasn't, what was your hardwood?
What's that?
It listed as hardwood. What was your hardwood?
Oh. The question was what kind of hardwood. We used mixed oak pellets. And just, I know it was a little confusing. I had yellow pine up there and I had loblolly pine up there. The yellow pine was obviously just a blend of southern pine, and then the loblolly was just straight loblolly. So, it was a little odd to me that we saw some differences there because, they're pretty much the same material, but we did see them. And that may just be, it is research and maybe our sampling techniques or something. These downdraft systems don't like the real fine particles. As we are gasifying through the gasifier there, we pull air through the whole bed, and if you get too many fines, you're going to see that you're going to get a lot of clogging in there. So actually on this system, right up under the bed, we have a filter system or a screening system that will remove the fine particles. So we have run some dust before, or a little bit of sawdust before, mixed usually with the biomass. We can get by with small amounts, but not large amounts. Our previous blending study we did was using poultry litter and blended it with pine. And there we did two different methods. One, we did just raw poultry litter, which was pretty much dust, mixed with pine chips. And the other one, we mixed poultry pellets with pine pellets. And that blending study for us was not a success. We still had a really bad agglomeration and weren't ever able to successfully get poultry litter through there. Part of the reason for that is the poultry litter was at about 25% ash content. So that's why we're really excited about this blending study that's come out so favorable.
How about poultry chips, bark on chips? I saw somebody had bark separated versus chip separated, but how does that impact the process?
Yeah, so the question was, can we run poultry chips? Oh yeah, we can run poultry chips. The nice thing about this gasifier is it's fairly flexible on what kind of biomass you can add in. So we've taken whole tree chips. We've worked a lot with Tom Gallagher in forestry and just take a whole pine tree, chip the whole thing, needles, everything. As long as we get the moisture content under control, we can then feed it in. I didn't really talk about it, but we did do a study where we blended bark with pine, clean pine. That was just really just to add an extra level to our blending. But we had good results and we expected good results. So, what we've seen on this gasifier is apart from the real fine material, we can gasify a lot of material as long as we can feed it in and get it through the gasifier. So, you know, a lot of times with your systems, your feed systems, you'll be set up for a chip or a pellet or a grass, and you design your feed system for a certain type of biomass. So as long as we can feed it in, we can usually gasify it. If we go to the lighter grasses, we have issues just getting it through the gasifier. But as long as it's a chip or a pellet, we can usually gasify it.
Does miscanthus, does it follow the same category as switchgrass in terms of ash content?
Pretty close, yeah.
Pretty close.
It would be really similar.
The question was, does miscanthus follow the same same switchgrass with ash content? And the answer was yes. I wouldn't know, but I haven't worked yet with miscanthus. Yes, the switchgrass was pelletized. We really wanted to, on this study, when we were blending the material, keep the blends uniform. So we blended pelletized switchgrass with pelletized pine. That way what we found before when we mixed materials that are different forms, like a sawdust with a chip or something, that you actually get some separation inside the bed. As this system uses vibration to move material through, so if you have different densities and all that, it's going to move through at different rates, and you actually get separation in there. Yeah, good question. The question is what kind of waste products we have on this system. Our main waste on this system is just going to be any ash that's in the biomass to start with, and whatever char is not converted. So all ash or char, we keep it in the gas stream, and it collects in the filters, which is the black box right there. And there's a flexible auger at the bottom of that filter. Periodically, we'll just auger that material out into a drum in the back of the trailer. We don't carry that with us. The amount of ash or char that comes out is very, very low. I think we've measured it to be about 0.6% of what goes in. So we did a study a while back. We ran about 3,000 pounds of biomass through the gasifier, and we quantified the char and ash together. We had about 16 pounds. So it's not much. It's a fairly low number. The only other waste product, I guess, in this system would be any syngas that's not being used. So I didn't really talk about this, but the generator is an on-demand genset. So if it is trying to generate 2 kilowatts, it's going to pull the fuel for 2 kilowatts. If it's trying to generate 20 kilowatts, it's going to try to pull the fuel for 20 kilowatts. But we're always flowing enough gas for full load to 25 kilowatts. So if you're not running at full load at that point, you're wasting syngas. You're flaring it off on the roof. The reason for that is we don't have the luxury on this system like you do in your vehicle to have a gas pedal that you can sort of press when you need more power and release when you don't need the power. On this system, we're always running at full throttle. And if we need it, we use it. If we don't need it, we waste it. So right now, we're probably only generating 2 kilowatts, so we're wasting a lot of syngas. We don't have a way on this system to compress and store it. We do have a compressor back home, but you got to do a lot of cleanup before you can really compress it, so we don't carry that with us. That's about all I have. I guess the only thing I'll add to it is I didn't mention it. Throughput of biomass on this system, 50 to 60 pounds per hour is what it usually uses. And for all our tests, we like to run a minimum of 200 pounds per test. That gives us roughly about 4 hours of run time. And what we found is that gives us enough time of biomass in the gasifier for it to, for us to see that it's actually doing something. Because what I mean by that is if you only run for an hour, you're still going to have a bed full of material there from your previous run. So 4 hours lets us get that gasifier pretty full of our own biomass, and we're pretty confident that what we have in there is the biomass that we want to be analyzing. I think I'll hand it over to Dr. Taylor.
Any other questions for Christian? Okay. Thanks, Christian. Our next stop is really the field tour, and I'm looking at Rich Shuren, Rich and Rick Stonek. I'll hand it over to you guys, and then you all can lead us and talk to us along the way. Does that sound all right? So Rick Stonek, Rich Shuren are both from Greenwood Resources, and then you may have some discussion later on with the folks from Auburn too. Is that right, or are you all pretty much leading the tour?